Ladies and gentlemen, if you are here for the first time, this is Dramani Online Mathematics. Make sure you subscribe and share to your colleagues, okay? We are just continuing with PMI. By this time around, you're going to look at when it's involved divisibility. So we already solved some example. You can visit my previous videos on the introductory analysis. So this is the question before us. Show that 10 to the power n minus 4 is divisible by 6. So when you see this mathematical statement, you know this one, for you to do that, we still use the PMI, that is the principle of mathematical induction, and the rules still uphold. Rule number 1 says that you should let n equals 1. Number 2 says that you should let n equals k. Number 3 says that you should let n equals k plus 1. The proof will actually be on n equals k plus 1. So let's start. So first rule says n equals 1. So when we have n equals 1, what happened? Anytime you have n equals 1, what happened here is very simple, okay? You just substitute 1 here to check if this will give you something that is divisible by 6. So let's see. So 10 to the power 1 minus 4, which is 6. So we say that 6 is divisible by 6, right? So it holds. Now we also move on to the next stage where it talks about, we should assume that n equals k. That's the assumption stage, right? So n equals k. When n equals k, if I put k, they will get 10 to the power k minus 4. Now these statements, we assume that it's divisible by 6. So we equate this one towards 6m, where the m belongs to natural numbers. In fact, what we are trying to say is that if this, we have seen that it's divisible by 6 because per what we've done is divisible by 6, then 6 by any natural number, when divided by 6, it will be it can divide without any remainder. So that is divisibility we are talking about. So let's move on. The last one, where you say that n equals k plus 1. Okay. What you are going to do is that wherever I see k, I put k plus 1 there. So let's see. 10 to the power k plus 1 minus 4. There is the idea. How do I solve? This is where you prove. The induction stage, that's where you prove. So what I will do here is that, let me name this one as equation 1. I'm going to do or manipulate this expression here to get 10 to the power k minus 4 from this. Okay. You know, from our indices, I can write this one as 10k multiplied by 10 to the power 1 minus 4. Is that okay? Now, if I factorize 10 out, look what happens. Here, 11 with only 10 to the power k. Here, 11 with minus 4. But you realize that this does not follow the principle of factorization. It's not correct. So for me to make this one correct, I just add this 36. So that if I multiply this by this, I'll get this. Then, I'll get this. If I multiply this by this, I'll get negative 40. But it's supposed to be negative 4. So if I add 36 to the negative 40, that gives me negative 4. So this is a correct statement. You realize that 10 to the power k minus 4 is the same thing here, which was equals to 6m. So I can replace here by 6m. So I have 10 bracket open 6m close bracket plus 36. Is that right? And here if I multiply through, I'm going to have 60m plus 36. If I multiply the 10 by the 60, which I can factorize 6 out. In fact, you can factorize 12 out, which is also divisible by 6. Okay. I can also factorize 6 out, so I prefer that, which is divisible by 6. So that here I have 10m plus 6. Okay. Like this. Let me represent the whole statement, this statement, by a letter. So let me represent the whole of this statement by, let's say, letter A. So I can say that this is multiplied by a, where the a also belongs to the natural number. What does it mean? It means that it is proven that this is divisible by 6, because this natural number, any natural number I put it here, if I multiply by 6 and I divide by 6, it will be possible without a remainder. So that is divisible by 6. So you conclude therefore by PMI 10 to the power n minus 4 is divisible divisible by PMI 10 to the power n minus 4 is divisible by 6. Is that okay? Thank you. Now let's look at another example. Right now, let's look at our example number 2. Okay, this is example number 2. Show that this statement n to the power n, 9 to the power n minus 2 to the power n is divisible by 7. The meaning of this symbol is for all natural numbers belonging to n. That is, for all n belonging to the natural numbers. Sorry, I beg your pardon. How did we solve this? Still, we are using the PMI. My first statement I have to make is that n equals 1. So when n equals 1, what happens? That's going to be 9 to the power 1 minus 2 to the power 1, which is 7. So it is proven 7 is divisible by this 7. So it is proven that. We move to the next one where it assume that n equals k. So let's put it there. We have 9 to the power k, 2 to the power k. And because this is divisible by 7, I can equate to 7a. Alright? Where you know that the a belongs to natural numbers. Now after this, for me, I want to make 9k the subject because I will use it for something. So 9 to the power k equals 7a plus 2 to the power k. Alright, let me name that equation 1. Now let's move on where we do the main proof by saying that n equals k plus 1. So we have n equals k plus 1. We're going to have 9 to the power k plus 1 minus 2 to the power k plus 1. So this is where the main proof will fall. Now let's do something here. 9 to the power k plus 1 can be written as 9 to the power k multiplied by 9 minus 2 to the power k multiplied by 2, right? But remember, we said that 9 to the power k is the same as 7a plus 2 to the power k. So we can do something about it. So in place of 9 to the power k, I'm going to replace it by 7a plus 2 to the power k. So I'm going to have 9 here multiplying 7a plus 2 to the power k minus 2 to the power k multiplied by 2. Very good. But also remember 7a plus 2 to the power k was given as okay. So once you get to this place, what do you do that you multiply through 9 7 is 63. So we have 63a plus 9 times 2 to the power k minus 2 to the power k multiplied by 2. This and that are like things, so I can factorize that one out. They are the same, they are the same. Even 9 minus 2. So 63a plus 2 to the power k multiplied by 7. This and that they have 7 as a common factor. I can bring it out, leaving 9a plus 2 to the power k. Something like this. Now I can replace the whole of this one. Since we have 7 out, we don't have a problem. I can replace the whole of this one by, let's say, letter m. I can replace the whole of this by m, where the m also belongs to the natural numbers. So I can have 7m. So indeed, it is proven. So we say that by PMI 9n minus 2 to the power n is divisible by 7. Okay, so this is how it is done. Thank you very much for watching. Try to subscribe and share.